everyone, and welcome to today's session. Let's shortly introduce ourselves. My name is Konrad Dąbrowski, and I am the engineering manager at CodiLime.
And my name is Paweł Mijowski, and I am DevOps engineer also at CodiLime.
Today we are presenting the topic of VNF deployment automation in the cloud. Before we get started, if you have any questions during the presentation, please type them into the chat on YouTube. We will collect them during the presentation. We will have time for questions at the end.
Of course, a recorded version of this webinar will be available on our YouTube channel, so let's begin.
Okay, so this is our agenda for today. So we'll speak which processes to automate in the cloud. We'll speak a little bit as well about the cloud automation example workflow and related tooling. Then we will say a few words about business and operational benefits of automation. Finally, we'll share the live demo where we are going to deploy some VNF in the cloud. And we will finalize with key takeaways and questions and answer session. So today the adoption of automation of cloud deployments is higher than whenever before. The Gartner survey with infra operation leaders says that usage of structured infrastructure automation is going to leap to 70% of organization in 2025 from just 20% in 2021, in the last year, in the previous year. So another survey with DevSecOps community done by GitLab is proving that 56% of operational team members said that they are already fully or mostly automated. So as we see, the cloud deployment automation is really there, and it's well adopted by the market. But which processes can we automate? The general target, the high-level target, is to minimize the toil. So all repeatable manual tasks that scales linearly as service grows. What it could be in practice. So we should automate the initial deployment of infrastructure, called very often day zero. We should as well automate the configuration of initial production config. So for example, configuration of DNS servers, radios, DHCP. So this is very often called day one. And then, last but not least, or maybe the most important, day-to-day activities called day two automation. So creation of new environments, backup operations, upgrades, control of our cost, control of expenditures, thanks to the automated tagging of the cloud resources. And last but not least, observability and monitoring configuration. So bringing automation in cloud deployment and configuration processes opens the opportunities to use the well-known and best code delivery practices in the cloud operations. Or maybe it's exactly in opposite, thanks to the good practices in cloud of code delivery, we may really well automate the cloud deployment. The automation workflow should be, in general, well designed. So here we show some simplified workflow to present you the high-level ideas that we may use. So with the approach on the diagram, we are using the infrastructure as code integrated with so-called GitOps approach. It means that we keep our infrastructure declaration, because with infrastructure as code, we declare what we are willing to deploy. We keep this infrastructure declaration described as code. This code is stored in the central Git repository. And then all changes to the infrastructure from deployment to to day-to-day modifications or configuration changes are passing the Git flow. So what does it mean? So as you can see, there are some engineers responsible for configuration of the infrastructure, deploying of the new VNFs, for example, or destroying of unused resources. They write or they specify everything in the code editors. What does it mean? So they are not doing that in the cloud console. They are not doing that on the device console or command line. They are specifying that as a code in code editor that are integrated with Git repo. They are committing their changes, their code to the Git repo, to the version control system in general. And thanks to the usage of this Git repo, the whole Git workflow is implemented, including as well the approval process called in the code development environment merging, for example, to the main branch. So version control system also ensures a single point of truth for cloud deployment or cloud infrastructure. So including what are the deployed resources, but also what's their configuration or specification. This is very important as it helps to keep consistency among the whole organization. So all the engineers are keeping everything in one single place. The Git repo ensures also by design the simple rollback procedures because it's which is extremely important in general in operations. And because the version control system, we can always easily come back to the previous commits, previous state of our infrastructure. So with such workflow, we can not only create, but also destroy the unused resources easily in exactly the same way like we deploy. So we have various both commercial tools, like Bitbucket, for example, or some open source platforms like GitHub. Okay, and then as a next step, we have deployment pipelines, which is in fact core of our automation. They are used for automated deployment, destroy, and also configuration of resources in the cloud environment, but allows also for some, for example, automated tests.
Yes, but pipelines can also do more complicated tasks, like do more advanced testing scenario, destroying unused resources, creating various reports, do server patching, or even automated rollbacks. There are multiple CD tools like Jenkins, GitHub Actions, GitLab CI/CD, Azure DevOps, or Argo CD that have very similar functionalities, but it's worth of spending some time carefully selecting one that we actually need based on running cost and effort of implementing it.
Yeah, thanks, Paolo. Exactly. So that's exactly that. So there is no one tool for everything. We should really select the tool that fits our needs. So finally, when our CD pipeline deployed our solution, tested previously in an automated way in the cloud. And of course, it might be one of the public cloud providers like GCP or AWS, but also in private cloud environments like VMware, Kubernetes, or OpenStack, because not each and every business can allow itself to have their workflows in the public cloud. With the approach that we just discussed, your deployments are quick, consistent, and not prone to human errors. So thanks to extended collaboration between team members following the Git flow, as each resource in the cloud is also related to certain OpEx, especially with public cloud, with such approach, we can easier control the cost by easily keeping in the cloud just the infrastructure we really need at a time. Proper tagging of different resources allow us also to distinguish what are the costs of production of particular services running in the cloud, because some of the resources are shared, some of the resources are dedicated for particular service. So the tagging really helps us a lot in following the cost of different services. And finally, as you can see on the bottom of the slide, you have really plenty of tools available on the market. They are really mature today. They differ not only in terms of functionalities, but also in terms of business and operational models. So it's really crucial to select the one that really fits your business the most. Okay, and what for? What for use the automation of the cloud in the cloud for the deployment? So thanks to implementation of the best market practices and approaches to automation, like GitOps or infrastructure as code, we gain really multiple benefits, both operational but also business. So using Git repositories, first of all, we gain one single place to keep our infrastructure, our single point of truth, which is extremely important. We also gain version control. So we control different versions of our infrastructure that we have in time. We increase the collaboration between different team members we've implemented by design process of reviews and approvals thanks to Git repos. And we enable automation of testing and validation and improve overall consistency of configuration of whole install base. That all brings clear business benefits like reduced human errors, enhanced scalability. Really doesn't matter how many virtual machines you wish to deploy in the cloud if you have it automated. Shorter time to market, and also, as I said already before, easy cost control.
Thanks, Konrad. So we would like to present to you a short demo where we'll demonstrate how quickly the changes in infrastructure are implemented when automation is in use. For the purpose of this demo, we'll deploy a simple web application. We prepare an environment in the AWS cloud. Here we have a VPC with 2 public subnets and 2 private subnets. We deploy the application load balancer, which is responsible for load balancing, routing the traffic to our application, and ensuring HA in 2 different zones. Also, we have AWS Elastic Container Service is running on a serverless compute engine called Fargate, and ECS is deployed in our private subnets. An application will be deployed in the ECS container located in the ECS cluster. We also deploy the internet gateway to provide internet access to our environment. We have already pre-deployed the infrastructure to speed up the demo since it takes a couple of minutes to deploy everything. This infrastructure is deployed with infrastructures called Paradigm. During this demo, we will introduce small changes to the initial infrastructure to present how easily we can scale the infrastructure when needed. For the purpose of this demo, we selected Terraform, which is multi-cloud infrastructure as code solution. The code defining the infrastructure is stored in version control system. Here we select GitHub, which we also use to implement the deployment pipeline, sorry. And we have also deployed a little bit of bash script, developed a little bit of bash script to automate the Terraform itself. And we use Python to state the web application and also treat it. We use Python to also run the application. We select this technology stack to demonstrate the GitOps and infrastructure as code Paradigm in practice. The implemented workflow minimizes the maintenance, potential human error, and time to deliver. The well-known challenges in the real life of CloudOps teams. I will be using AWS console to show the nodes of the application, also the GitHub to show the pipelines where Terraform will be running, and application window to show the current application nodes. Yes, so I will be changing my windows to show you the wider view of the whole environment. Okay, So I would like you to present to you the few pieces of the code which is responsible for each part of the demo infrastructure. Let's start from the ECS cluster, which is responsible for running our application. We have code for creating the ECS cluster here. Also, we have a few lines of code for our service, which is our application, and task definition, which is responsible for spawning the node of our application. Also, here we have the IAM, which is our permission boundary. We here treat IAM with the methodology of least privilege, so we treat it securely, and only this permission needs to be set to able the application to work correctly. Here we have the few lines of code defining our application load balancer. We have balancer created here with also the target group to the balancer. Sorry, this is the listener for the load balancer, and this is the balancer itself. As you see, this is very little piece of code here. And last but not least, we have here our VPC, which is our virtual network. We have subnets here, security groups, and also internet gateway, routes necessary for routing our traffic. And okay, now let's see it in AWS console. So as I say, here is our VPC we created based on the code I was showing you previously. We have our VPC with our private and public subnets. Both are in separate availability zones. We have also the route table and internet gateway in front of it. Here we have our load balancer with our listener forwarding to our application. The route is forwarding to our application. Our ECS cluster, Elastic Container Service Cluster, which is responsible for running our application. Here is our service, which is definition of our application, let's say it, and one node of our application, which is already deployed. And here, if we go to the application itself, I can refresh it a couple of times, and you see nothing is changed. We are in one node and one availability zone.
Yeah, so Pavel, may you come back maybe to the presentation to slide number 7. So as Pavel explained, we have a load balancer which role, one of its role here is to balance the traffic to different containers. But in the initial deployment, we just deploy one container. So as on the next slide, Pavel, you make, yeah, so we have, for the initial configuration, we have just one container. And then if you come back again to the web server, to the application on the...
oh, okay.
Yes, here, so when Pavel refreshed the page, we are hitting the load balancer, and load balancer should load balance the traffic between different containers. But because there is just one container, the traffic from load balancer is always hitting this one single existing container. So here we have the ID of the node and also availability zone. So it's always the same. Nothing changes here. And that's not a fault. That's by purpose. It's not a bug. It's a feature. Okay.
Okay. So now let's imagine that we have high traffic on this application, and one node can handle it. We need to add more nodes of the application. We can do it manually or automatically. For the purpose of this demo, we will show you the manual approach. So now let's see how quickly we can do that using automation. Let's go to the code editor.
Or in fact, it will be semi-manual because we will not create manually through the console. We will just specify it as code in our Terraform TF-vars file.
Yes, exactly. For us, it's a manual approach, but of course, we can do it better using the more sophisticated automation, let's say, and other services. But let's go back to the demo. We want to spawn another three instances, so all nodes will be 4. Let's change this. So right now changing only the one parameter in the code. I will comment the changes, and I will do it through my code editor. And when I'm commit this and push it to the repository, the pipeline itself will start to run our bash script, which run the Terraform itself. Let's do this. So I am pushing the code to the repository. Let's see it here. It should be visible right now. Okay.
So once the changes were done in Terraform, and committed to GitHub, the pipeline is started automatically, as you see.
Yes.
And is running the stages designed by Paweł.
Right now, the Terraform initialized itself. We have done the quick validation check using the Terraform validate option, and Terraform right now applying our changes to the real life infrastructure. We can see we're changing the desired count of the node application we want. And we can see it's already done. It takes like 20 seconds. So let's go back to the infrastructure. We need to wait a couple of seconds. Okay, the new nodes of the application are starting to run. We need to give it a couple of seconds more. Of course, in the real life, in real case scenario, we don't need to manually add the new nodes of application. A much quicker way to do it is using the auto-scaling group and scaling plans to automatically add new nodes based on the application metrics. But we want to show you how quickly you can change the infrastructure part. Okay, I think everything should be okay right now. Let's go back to the application. And when I hit the application a couple of times, you can see we hit different nodes itself. And also the availability zones is changing, which ensure our application is running in HA.
Yeah. So in fact, AWS spreaded multiple containers among 2 different availability zones, which are in fact geographically spreaded. So that's also showing the way how to bring some redundancy for your web application or the other application that you have, and to protect yourself against some, for example, problems or issues on the cloud provider side, where, for example, one geographic location is somehow hit by some disaster. So that's the way how we can spread our service among multiple geographical location very, very easily by just specifying amount of containers like shown here.
Exactly.
Maybe the one thing, one comment regarding the pipeline, the deployment pipeline that we used was in fact very simplified. And for example, there was not a wide range of testing. There was just the Terraform validate, but we could add the stage, for example, to some more sophisticated static code testing or some end-to-end testing to see if the deployment were properly. So we just simplified for the sake of this demo.
Yes, of course, and we can also apply the security test when we do it in a production way or so.
Yeah, so to check, for example, for potential vulnerabilities
Yes, exactly.
in the code.
There are multiple tools for using that, and in multiple occasions we already are doing the pipelines. We check that kind of stuff also to ensure that nothing will pass our real life scenarios.
So I hope you like the live demo. To summarize a bit our today presentation, so really automate your deployment in the cloud today. There is nothing, no reason to wait for. The cloud deployment automation is really natural path because all the cloud providers think about the automation exactly from the beginning. They develop the automation tooling exactly from the beginning. We should automate various operations and minimize the toil, and minimize all the manual repeatable job. There is really today a wide range of major tooling provided by both commercial providers and the open source community, so you can really pick those tools, those solutions that really fits your business. And last but not least, we shown today the live demo with the public cloud, but of course you can automate the deployment as well in your private environments, in VMware or whatever, dependent on your needs. Not all the business really can afford keeping their workflow in the public cloud, which is obvious. So that's also possible, and the range of tooling is as well mature and ready. Okay, so I think now it's time, Pavel, for question and answers. So do you have any questions to us?
I will check our meeting chat. Maybe we have something.
Don't be so shy. We are ready to answer your questions. Hope we'll know the answers.
Okay, we have one. Why did you select ECS on Fargate as compute? So I can answer this question. We select the Fargate since we want to use the serverless solution because we want to minimize the maintenance of the infrastructure, also cost of our deployment. And there was no need to create additional resources because there's a way to create cluster also in EC2 instances, but we don't need that in our solution, so there were no point of creating that.
Yeah, it may have sense if the environment is much more complex, but in such a simple scenario, the serverless solution was fully capable to do the job and not to think about the maintenance of some complex environment. It was very straightforward to go.
Yes. Do we have any other questions?
Let's give a chance to our audience.
So why Ansible is not on the list of example tools?
Why Ansible is not on the list of example tools? Okay, that's a very good question. In fact, so there are Ansible and, for example, Terraform that we were presenting. Those are quite different type of tools. they have plenty of differences, starting from the fact that I think that Terraform is declarative, Ansible is procedural. That's one thing. Second thing is that Terraform is idempotent. And the third one is that Terraform, for example, Terraform or CloudFormation, for example, which was as well presented as an example, is for immutable infrastructure. So with the approach that we presented, that could be used both for deployment of the infrastructure, but as well for configuration of the VNFs running on the computes in the cloud. You are keeping the state of your infrastructure all the time, and whenever you change anything in the configuration, you are always aware about what's going on there. With Ansible, there are many organizations that are mixing the Terraform with Ansible, for example, deploying the infrastructure with Terraform and then configuring it with Ansible, which is a, let's say, approach which is working as well. But from the moment when you start to configure an infrastructure with Ansible, you lose, from the point of view of Terraform, the control what is configured there. Ansible, but I don't want to say that Ansible is a worse tool. It's a very good tool, and for many operations, like for example upgrades, Ansible is a perfect one. But in the solution that we presented, we really push or we really encourage the workflow in which you are from the beginning to the end aware about the state of your infrastructure in infrastructure as code tool, in one central place like Terraform, for example. Are there any other questions?
Yes, we have one. How does this work with OpenStack, in case you have tried?
So you have as well, for example, Terraform provider for OpenStack as well. We check it. I'm not sure personally. I don't have experience with setting the OpenStack with Terraform, but the provider is there. OpenStack is quite popular. And by the way, beside OpenStack, Terraform, for example, have like more than 1,000 different providers. So I think that should be quite okay. But if you are willing to have more information about that, please write us on the email provided on the chat.
Do we have any more questions? Okay, we have one. What's the time of deployment of all infrastructure presented in the diagram? So the whole time of the deployment was like 6 minutes or so. So it was very low time, and everything was deployed. The whole changes, as you see, was very quick. It took like 20 seconds to run the pipeline, and the whole changes took like 2 minutes to able to see it in AWS, also in our application. So the changes was very quick. So the whole deployment is like a minute with the changes. So it is very quick run.
Okay. I think we don't have any more questions on the chat, so it looks like we have covered all the topics. Is there anything else you wanted me to mention before wrapping up?
I think we are good for now. Thank you everyone. It was a pleasure being with you today. If you have any question, you can contact us by mail, team@codiline.com. Also, we'll leave the details on the chat, just a couple of minutes.
Okay, so I have small announcement at the end. After this webinar, you will get a very short survey about your impressions. Me and my team will be very grateful if you left us some feedback. So thanks to that, we can constantly improve our webinar. So thanks in advance.
Thanks again for joining us today, and we'll see you all next time around.